This meeting is being recorded.
So we've looked at how to predict products in the last couple problems. 8.7 asks us to draw a mechanism for each of these transformations. So let's look at A here, example A. So we start with our six-membered ring. We have our double bond coming out of the ring, and we're going to treat this with HBr. So our final product, it appears to have added, right, across the double bond in a Markovnikov fashion. So let's take a look at what's actually happening behind the scenes with this mechanistic approach here. So we have this bond between hydrogen and bromine. This double bond will act, right, will attack, right, this hydrogen here, and we'll see a proton transfer, and then our intermediate product will look like this, right? We'll have a carbocation created, a tertiary carbocation, and what happens in this next step is the bromine, right? So these electrons involved in this bond have hopped over to the bromine, so now we have a bromine anion over here, and that will attack this site here where the carbocation is. So our final product of this mechanism is what we see above. So we already have that methyl group coming out, and now we have a bromine that has added in the same site. The next two problems are very similar as far as the mechanisms go. We're going to see a proton transfer followed by a nucleophilic attack. So let's see here. So we have, right, our double bond in our second molecule here. We'll again grab that proton, the electrons involved in that bond, hop over to the chlorine, and then we end up with, right, our carbocation intermediate at this site here. So that chlorine will then do a nucleophilic attack at that site there, and that's where we end up with this final product after that nucleophilic attack. So the same steps involved again, right, with our third molecule here. So we have our proton transfer in step one, and then we have our, right, a carbocation intermediate would form over here at the tertiary site, and that's where we have our nucleophilic attack of the chlorine, and hence our final product here.